Today we're going to begin chapter 4, and we're going to start with section 1, and we're going to deal with rational functions and asymptotes. So the most basic rational function is 1 over x. And again, rational functions have variables in the denominators. And if you look at the coordinate plane in this page, you're going to see the graph, and the graph's kind of weird. We're not used to seeing a graph like that. Notice that you have, in quadrant 1, you have this portion of the graph, and you notice that the graph hugs really close to the y-axis, but it never actually touches it. Same over on this side. It hugs really close to the x-axis, but it doesn't really touch it or cross over it. And you notice the same thing for the other side. It hugs really close to the axis, but doesn't touch it, and it hugs and it doesn't touch it. Well, these axis lines in this particular graph represent our vertical asymptote, okay, and our horizontal asymptote. And so we're like, well, what does that mean? Well, vertical asymptotes are these lines, imaginary lines, if you will, where the graph will never cross. So vertical asymptotes, the graph never touches or crosses this line, okay? Now, when it comes to horizontal asymptotes, you might see the graph sort of kind of hug over it, maybe cross over and back, but as it approaches infinity, it will end up getting closer and closer to it without touching it. So it sort of hugs this one, okay? Hugs this asymptote as it approaches infinity. And so it can cross this one, but basically it hugs it. And again, we're talking about as numbers approach infinity, which are really big numbers. So let's try to understand these limits that it's talking about here and these weird words that it's saying. And in this one here, what it's saying is that remember, f of x is your y, which is your output, okay? So as your y value or your output approaches positive infinity, x will approach 0 on the positive side. It'll get closer and closer to 0. So let's look at this quadrant here and kind of identify as my output. Notice my output is getting closer and closer and closer to positive infinity because it's going up, 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 right? So it's approaching infinity. And notice that as that's happening, my graph is getting closer and closer and closer to x is 0, okay? Which is the y-axis line is where x is 0 from the positive side. And then on the negative side, notice that again, as my y or my output approaches negative infinity, that's down here. Notice my graph is approaching negative infinity here. My graph is approaching x is 0 from the left side or the negative side. That's what this is saying. And so again, that value it's approaching but not touching, that's your vertical asymptote, okay? Now, the horizontal asymptote shows you, it says again, as your y value or your output approaches 0, your x is approaching positive infinity. So again, let's look at our, this is the bottom one we're looking at now. Let's look at where my output is approaching 0. My y values are approaching 0. Well, that's, for example, over here. Notice my y values are getting closer and closer to 0, and as that's happening, x is approaching positive infinity over here, okay? And on the bottom graph, as my output is getting closer and closer and closer to y equaling 0 or f of x equals 0, my x is approaching negative infinity. And so that's all these things are sort of telling you. So we have to learn to find the asymptotes from an equation, basically, or an expression. So when we get a function and they ask us to find the asymptote, I'm going to show you how to do it as opposed to just this list here. But basically, the vertical asymptote, let me just kind of give you some examples here. So you're going to set the denominator equal to 0, and whatever value that is, that's the line that it cannot cross. So for example, on this one, let's say that I have 1 over x plus 2, okay? I know that x plus 2 cannot equal 0. So if x is negative 2, it equals 0, and that's not okay. So this equation represents our vertical asymptote, okay? And we might just call it VA. So the line where my graph is not going to cross is going to be the line of x equals -2. And that's how we find our vertical asymptote. So we set the denominator equal to 0, find that x value, and that's the equation of that line. Remember, since asymptotes are lines, they're going to be written as equations of lines, okay? You can have more than one vertical asymptote. We'll get to the examples of those as we work. Okay, now your horizontal asymptote, this is something like we discussed. It will be a line that, you try not to cross it, but as you approach, as you start going along, you may cross it at some point, but you're always going to be hugging the line. But as you get to bigger and bigger numbers, you're just getting closer and closer to that line. Now, what you're going to look at there is the degree of the exponents, okay? You're going to call the degree of, this is just the formal way of doing it, but the degree of the numerator, the highest exponent in the numerator is going to be n. The highest exponent in the denominator is going to be m. And if the exponent at the top is going to be bigger, so for example, for this one, let's say, okay, so if it's less than, let's do that one first. So if we have, x over x squared, okay, or even let's do x plus 1 over x squared plus 1. Notice that the exponent in the top is 1 and the exponent at the bottom is 2. So the one at the bottom is larger, okay? Well, that's going to be then, your asymptote is going to be the line of y equals 0, okay? So if n is less than m, it's going to be y equals 0, okay? And again, you have to think about that. If I do this equation, let's think of really big numbers, right? Let's think of, a million. The plus 1 and the plus 2 are irrelevant if I'm talking about large numbers. But if I do a million to the first power over a million to the squared, you know that my denominator, as I go to infinity, my denominator is going to get huge, way bigger than my top number. And when the bottom is bigger than the top, your fraction just becomes smaller and smaller and smaller, okay? And so you'll approach 0, which is what this really is talking about. In the second case, what happens when n is greater than m? Well, when that happens, and an example of that would be something like maybe it's x squared plus 5 over x. And in this case, there's going to be no horizontal asymptote, okay? Now, when there's no horizontal asymptote, you're going to have a slant asymptote, and we're going to talk about that after, okay? So let's do the last case where you are going to have a horizontal asymptote, and that's going to be when n is equal to m. And so, again, let's do an example of that. Maybe like 3x squared plus 7 over 2x squared minus 4. So, like we've talked about, we already canceled these out. And when the powers are the same, we can cancel those out. And our equation is just going to be the coefficient of the numerator, which is 3, over the coefficient of the denominator, which is 2. So the line of y equals 3 over 2 would be the asymptote. Remember, asymptotes are lines. And in all these cases, my lines are all going to be horizontal because, again, it's a horizontal asymptote. Now, so if we come over, so if n is greater than m, you're going to have no horizontal asymptote. However, if you do have the scenario where n is 1 more than m, you're going to have what's called a slant asymptote. So you're going to have a line, right, that is going to be not vertical or horizontal, but rather slanted in some way. So you know that any equation, any line that is slanted is going to be in the form of y equals mx plus b, right? This would be like minus mx plus b, right? I'd have a negative slope, but bottom line is, it would be a positive or negative slope, but it would look like that. And so I'm going to show you how to identify these. So the slant asymptote exists if n is 1 more than m, and to find it, you're going to divide the two polynomials. I'm going to show you how to do it, and you're going to ignore the remainder. So what does that mean? Let's say that I have, maybe I have up here x, let's do, x squared plus 2 divided by x plus 1. Okay, so this is kind of like my original expression. And I noticed that the top exponent is greater than the bottom, and it's greater by just 1. So I already know there's no horizontal asymptote just because it's greater. But because it's greater by just 1, I can find my asymptote. I can find my slant asymptote. So what I do is I take the top one. I'm going to do 0x plus 2, and I'm going to divide it by the bottom one, okay? And I'm going to do my normal division. You know how to do this. It's going to be x. It's going to be x squared plus 1x. Subtract, subtract, cancel, minus 1x. Bring down, right? We've done this before. And I know it's going to be minus 1. And at that point, I could technically stop. I mean, obviously, if I was dividing, I would be doing minus 1x, minus 1, you know, opposite, opposite. I'd get 3. And I have this remainder. Well, we don't care about that. Notice as soon as I plug the negative 1 in, this answer was in y equals mx plus b form. And that's all we care about. So y equals x minus 1. This represents the equation of the slant asymptote. Okay, and so this is how we find it. So it's not a vertical line, it's not a horizontal line, it's not a vertical asymptote, therefore it's not a horizontal asymptote, but rather it's a slanted line, and we call it a slant asymptote. And so, again, that's how all of these are solved. So again, we're going to do a lot of this, but just like to give you a visual, you know, a vertical asymptote and a horizontal asymptote, let's say, I would come over to my graph and notice that in this one, my vertical asymptote was x equals negative 2. So I would do, you know, do it in red. You know, here's my invisible line that my graph isn't going to cross. And then my horizontal asymptote that I kind of drew here. I have 2 different ones that I drew. Let me use, I'll use the one that's not on the axis line. So y equals 3/2. So again, we'll do 1, 2. So I know that 3/2 is between 1 and 1.5. And so here's my horizontal asymptote here. Okay. And then my graph would be something that would look sort of like that. And so again, you're going to use your graphing calculator to actually do the graphing. But understanding where the asymptotes are is really, really important. So you might say, well, how does that look different when I have a slant asymptote then? Well, again, let's do our basic line, right? And then what we're going to do is we'll come back and we'll still make the vertical asymptote this one, okay? So let's come over to here, and our vertical asymptote is still at negative 2, right? And then I know my slant asymptote is the equation of y equals x minus 1. Well, you know how to graph that. It goes through negative 1. It has a slope of 1. And so my slant asymptote may look something like this. So that's your slant asymptote. This is your vertical asymptote. Remember, there's no horizontal in this one. And so my graph, again, you're going to use your graphing calculator, but it'll look something like that and like that. Be this like little curve. And so it's kind of cool. And again, our calculators are going to help us, and we're going to do a lot of practice on graphing moving forward. Today, our focus is going to be on just identifying our asymptotes, whether they're, you know, the vertical ones, the horizontal, or the slant. And we're going to learn about a hole in a graph as well. Now, sometimes we have holes in our graphs, and so if I kind of go back to, you know, one of those other graphs we did, let's just pretend, I mean, again, I'm just kind of making this up, but let's say we have, you know, our vertical asymptote here, let's say we have our horizontal asymptote there, and our graph, you know, is going to look something like that, okay? Sometimes you might have a value, you know, maybe like at, you know, I don't know, 1, 2, 3, 4. Let's say where x is 4, where you're going to have a hole in the graph, where, you know, at some coordinate, you know, 4 and some number, you're going to have an undefined value, okay? You can't have, you know, a y value at that x value. And so it won't show up on your graph. It'll show up on the table maybe with an error message. You know, when x is 4, you'll get this error for your output, or your y. And you won't really understand where that's coming from, and you won't even be able to see it on the graph. But you'll know how to recognize where the hole might be if it exists, and I'm going to teach you how to identify when it happens, okay, and how to come up with this value. So again, a whole exists when you can simplify the function by crossing through a factor in the denominator. Okay, so let's see, what does that mean? Let's say, for example, I happen to have the expression, let's say I have x plus 1 over x squared minus 1. Well, when you expand this out, it's going to be x plus 1, and it's going to be x plus 1 over x minus 1, like that, right? Or x plus 1 over x plus 1 times x minus 1. And if you notice, you have this repeated factor that you can cancel. You can cancel these two out. And, you know, you're going to want to do that because imagine, you know, you always want to simplify your fractions. But the reason is what happens, there's got to be some kind of x value here that's going to make this denominator equal to 0, right? If x happens to equal -1, then I'm going to get 0 over 0, which I can't have. I can't have anything over 0. So I know that x cannot equal -1, right? And so because x can't equal -1, that's the point where I'm going to have a hole in my graph. It's going to be -1 for x, and I'm going to have some y value that is going to make up that point where that hole exists, okay? So again, when we have a thing like this, yes, we can cancel it, but we have to remember that in the original, x could not equal 1. So we're going to have now this new version, this 1 over x minus 1, this simplified version, which we're going to use. We're going to find our vertical asymptotes using this. We'll find our horizontal asymptotes using this one, the original. But now we're going to use this -1 to identify the value of our hole. And so I will use this new one as well, the one where the terms have already been canceled out, to find the hole. What I'll do is I'll plug -1 in for x, and I'll figure out what the value is. So I get -1/2. So when x is -1, the y value is -1/2. And this would represent the coordinates of the hole. That's where the hole in the graph would be located. And you just do an open circle at that one point, and the rest of the curve continues. So to find the coordinates of the hole, you find the solution that you crossed out, basically what value makes that 0 in the denominator, and you find the y value by plugging that x in, this x that you found here, you plug it into the simplified equation. You're going to find your vertical asymptotes and your holes using the simplified equation. So let's do some. So we're going to come over here and we're going to start to find our things. It says find the horizontal, vertical, and or slant asymptote. So they want us to find everything here, which is a little strange because in a subsequent slide they only want one of them, I think. But it's okay. We're going to find them all. Let's come over to here and let's start with our vertical asymptote. So again, our denominator cannot equal 0. So we have to figure out what makes it equal to 0, and that becomes the equation that represents our vertical asymptote. So that's it. It's the vertical asymptote is the line of x equals 1. Our horizontal asymptote, I'm going to look at my x values. Now, I don't see an x in this numerator. Remember, when you don't see it, it's like an x to the 0 power. So if you notice, the denominator has the higher exponent, right? The degree. The top degree is 0, the exponent at the bottom is a 1, and when you have this scenario where the top is greater, the bottom one is greater than the top one, your horizontal asymptote is just the line of y equals 0. So it's the x-axis, really. And so there's my horizontal asymptote. And so I know that I have my vertical asymptote, I have my horizontal asymptote, and I'm done. If I have a horizontal, there's no slant, obviously. And that's it. There's no holes because nothing's repeated. So let me go to the next one. So here again, I've got this equation. I'm going to start looking for my vertical asymptote. I know that the denominator can't equal 0, so I try to figure out what makes it equal to 0. And I know that -2/3 is going to make it equal 0. So the line of x equals -2/3 is my vertical asymptote. Okay. My horizontal asymptote, when I look over to here, I see that my x's are the same power. Remember, these are irrelevant. And when the x's are the same, these are going to get canceled out. And so I know that my horizontal asymptote is going to be the line of y equals 2/3. It's going to be the coefficients of those x squared, or x's. And that's it. And because there's no repeated factors that I'm going to cancel out from the top and the bottom, there's no hole here. So notice I don't think any of these on this page have a hole. They're not even asking me to find it, right? So now I'm going to go to example 3. And again, I'm going to start with the same process, the vertical asymptote. I'm going to take my denominator, I'm going to set it equal to 0, and I'm going to figure out what makes it equal to 0. Whatever that is, that's my vertical asymptote, the line of x equals -2. Now for my horizontal asymptote, when I get here, I look at my equation and I notice that the degree at the top is greater than the one at the bottom. I cancel the rest out. So I know that there is no horizontal asymptote in this graph. So the horizontal asymptote is none or no. Now I have to determine, I know it's going to be, if the degree at the top is 1 more than the one at the bottom, then I know that I'm going to have a slant asymptote. And it is, because 2 is 1 more than 1. And so I know in this problem, I'm going to have a slant asymptote. So how I find that is I divide the top by the bottom. I'm going to do a little placeholder here. So I'm going to start with x. I get x squared plus 2x minus 2x plus 1, and I do minus 2 here. Now again, I can keep going, but I don't need to, because once I have this, it's already in y equals mx plus b form, which is what I need. I don't need to go all the way down to get to the remainder. And so my slant asymptote is the equation of y equals x minus 2. And so I have a vertical asymptote and a slant asymptote and no horizontal asymptote. So in this slide, you can see that the problems start to get more complex, right? And again, we're still looking for asymptotes, but we're also checking for holes this time. So you can notice already some of these can be factored. And so, of course, we're going to factor them when possible so we can look for holes. So the first one is not something where I can factor the numerator and the denominator. So I'm just going to do, so this one does not have any holes. So I'm just going to start looking for my asymptotes. So again, the vertical asymptote is going to be, I'm going to set the denominator equal to 0, and I'm going to find the x value that makes that happen. So I get x squared equals -1/3. So x equals the positive and negative square root of -1/3. And at this point, you realize you're going to have an I somewhere, right? The answer's not I, it's I something, but you notice that you're going to get, your solution is imaginary. Let me do that, right? It's going to have this I value in it. Well, remember, our asymptotes are on the coordinate plane. The coordinate plane represents real numbers. And so there is not going to be a vertical asymptote because this line or these lines are not going to be on the coordinate plane. So there is no vertical asymptote in this problem, okay? Which is fine. You don't always have to have them. The next thing we're going to look at is the horizontal asymptote. And so we're going to go over here and we see that the numerator is x to the first, the denominator is an x to the second, the denominator has a higher power, and so this is just going to be y equals 0. And so these are our two answers. No vertical asymptote and y equals 0 for the horizontal. I'm going to go to the next problem. Now this one can be factored, okay? However, you're going to notice when you do factor it, right, you're going to get x plus 1, x minus 1, and you're going to see that there's nothing repeated, right? So there's going to be no holes here, just like in the last one, okay? So no holes. So I'm going to start looking then for my vertical asymptote. And again, I know my vertical asymptote is this denominator cannot equal 0, x squared equals 1. So I'm going to get x equals positive and negative square root of 1, which is plus minus 1. So notice here, I'm going to have two vertical asymptotes. I'm going to have x equals, the line of x equals -1, and the line of x equals positive 1. And so I'm going to have two vertical asymptotes, which actually is okay. And when we start graphing, I'll show you what that kind of looks like. Then we're going to go over to our horizontal asymptotes and figure those out. So again, notice back at the original exponent is 2. The original exponent here is 2. So remember how we do that is we take the coefficients that are in front of those two. So it's going to be y equals 2 over 1, or just the equation of y equals 2. And again, there were no holes, and so I'm done. Now we're going to get to some that most likely have holes, right? I don't think they'd ask us to check for holes if they didn't have any. So again, we're going to just start out by factoring our equations, right? So we're going to get here x plus 2 and an x minus 1. This bottom one factors to x minus 3 and an x plus 2. And so you notice that the x plus 2 and the x plus 2 are going to cancel out, leaving you with this simplified thing, and that's fine. We're going to use that simplified thing, but because the x plus 2 was repeated, this is going to have a hole, okay? So now, what value is our hole going to be at? Well, remember, what value is going to make x plus 2 equal to 0? Well, that's negative 2. So I know the x coordinate of my hole is negative 2. Now I need to figure out what the y value is. So I will plug negative 2 into the simplified equation. So I'll do negative 2 minus 1 over negative 2 minus 3. I'll get negative 3 over minus 5, which is 3/5. So I know that at this ordered pair, negative 2, 3, 5, my graph is going to have a hole, a little open circle at that specific coordinate. So that's one part of my solution. I'm also going to use this simplified version to identify my vertical asymptote. So again, the vertical asymptote, I'm going to take that denominator, x minus 3, make it equal to 0, and I know that if x is 3, it equals 0, and therefore this is my vertical asymptote. So I have my vertical asymptote, I have my hole, and what I need now is I need to find my horizontal asymptote. Now, for the horizontal asymptote, we're going to look at the original. Cancel all of these other things, and we're just going to look at these leading terms. Notice the exponents are the same, and when they're the same, your horizontal asymptote is y equals the coefficients of those. So y equals 1 over 1 or 1. So my horizontal asymptote is y equals 1. So this is all the math required to solve for the hole, to solve for the vertical asymptote, and to solve for the horizontal asymptote for number 3. And then let's go to the last problem here. So in this last problem, again, we're going to focus on simplifying first. And when I do the math here, I'm going to get 3x. I'm going to get 3x minus 2 times x plus 3. And at the bottom, I'm going to get x plus 3 and x plus 1. And yet again, we see this repeated thing. So we know our graph is going to have a hole in it. The x value of the hole is going to be negative 3. And what I'm going to do is I'm going to take the simplified version, which is 3x minus 2 over x plus 1, and I'm going to plug that negative 3 into that. So it's going to be 3 times negative 3 minus 2 over minus 3 plus 1. And when I do the math, I get negative 9 minus 2 is negative 11 over negative 2, or 11 over 2. And so this is the ordered pair associated with the hole. For my vertical asymptote, I'm going to use the simplified version as well. And so again, in that simplified version, right, this is the simplified version over here, okay? I know that my denominator is x plus 1, and I know that that cannot equal 0. So if x is negative 1, it's going to equal 0, and so that's my vertical asymptote. And then for my horizontal asymptote, I'm going to use the original equation. I know all this other stuff is kind of extra, and this is what I need to focus on. I notice my exponents are the same. So my horizontal asymptote is just going to be the equation of y equals the 3 over 1 or 3, right? So y equals 3 is my horizontal asymptote. And so again, really easy to find. It becomes very repetitive, and we'll keep doing more of these. And so now we're on to our last page, and again, we're going to continue to do the same things. And so this first one is already sort of, it doesn't need to be factored out. Everything is already fine, so there's no holes. The vertical asymptote, again, is going to be 3 plus 2x. I'm going to try to figure out equals 0, right? I got to figure out what value makes the denominator equal to 0, and I'm going to get x is negative 3 over 2. So the equation of x equals negative 3 over 2 is my vertical asymptote. I'm going to go to number 6 here, and I look at this one and I recognize that number 6 can be factored. So I'm like, okay, x plus 3 over x plus 3 times x minus 3, and I see that this can be canceled. So I know there's going to be a hole, right? I know the x value of the hole is going to be negative 3. And so what I'm going to do is, I know that I have a simplified version of this equation, right? I know it's going to be, let me actually do it on the side. The simplified version is going to be 1 over x minus 3. So this is my simplified version. And I'm going to use this for the whole. So I'm going to take the negative 3 and I'm going to plug it into here. And I'm going to get 1 over negative 6. And I know that negative 1/6 then is the y value of my whole. So I have the whole of my graph right there. Then I go to my vertical asymptote, which also uses the simplified version. So I'm going to put that denominator equal to 0. And so I know my vertical asymptote is the equation of x equals 3. And my horizontal asymptote uses the original equation. Okay, so my horizontal asymptote is going to look at this equation, and it's going to look at these exponents, and it sees that the bottom exponent is larger than the top, and so that one becomes really easy. That's just y equals 0 when that happens. And so there's my whole, my vertical asymptote, and my horizontal asymptote all there. For number 7, again, I see that I'm going to have to do some factoring here, so I'm going to start with that. So let's do that. So this numerator becomes x minus 2 times x plus 2. Then over here, I'm going to have an x minus 2 and an x minus 1. And so I realize that the x minus 2 is repeated. So I know my simplified version of this equation is x plus 2 and x minus 1. And I'm going to use that because I'm going to find the whole. Okay, I know the x value of my whole is going to be 2. Because if x is 2, my denominator is going to be 0, and I can't have that. So my x is 2, and I'm going to plug that into the simplified version here, and I get 4 over 1, or 4. So when x is 2, y is 4. That's the ordered pair for my whole. Now I go to my vertical asymptote. Again, I use the simplified version. I know the denominator cannot equal 0, so x equaling 1 would make that happen, and so that's my vertical asymptote right there. And then I know that my horizontal asymptote, I have to look back at the original equation. Again, I've got this 1x squared, 1x squared. The exponents are the same, so I know the horizontal asymptote is y equals 1 over 1, or y equals 1. And so this is my horizontal asymptote, and so that's it. So as you can see, I think it gets easier and easier and easier as you go. Again, let's do this last one. Again, we start out by factoring. So we get x plus 2 and an x minus 1. Down here we get, when we do the math, I'm going to get 2x plus 1 and x plus 2. And again, I notice that x plus 2 is repeated. So I want to recognize which is my simplified version, which is this one, x minus 1, 2x plus 1. And again, we use the simplified for the whole, and we use it for the vertical asymptote. So again, I know I'm going to have a whole because I have that repeated factor. So I know the x value of my whole is going to be x is negative 2, because that's what would make it equal to 0. And then I'm going to take that x and I'm going to plug it into the simplified version. 2 times negative 2 plus 1. I'm going to get negative 3 over negative 3, which is 1. And so here is the whole of my graph. From there, I go to my vertical asymptote, which I also use the simplified version. So I know 2x plus 1, it can't equal 0, so I'm going to figure out what would make it equal to 0. And so this is my vertical asymptote, because if x is negative a half, then my denominator will be 0. And then lastly, I'm going to go towards and look for the horizontal asymptote here. And again, all this is extra for that. I'm going to look at the original, I'm going to look at those leading terms. My exponents are the same. And so I know that it's going to be y equals the coefficients of those x squareds. And so it's going to be y equals a half. And so that's it, guys. So again, the purpose is to, factor if necessary, identify any holes that you have, find those coordinates. The holes are an actual ordered pair. And then you're going to find your vertical asymptote. If you had a hole, then you simplified your fraction. So the vertical asymptote will use that simplified fraction. And then find the horizontal asymptote, which always goes off of the original expression.